I wanted to talk about performance a little bit. I know you've been working on the topic. There is one segment we recorded about React Native performance, which we didn't release. Maybe we can talk about it here. So I know it's a topic you've been working on. I've been working on this topic. And I had the realization that, I don't know if you agree, but for us, React Native performance, it's almost like fun because we like to dive into the topics, like going deep, and we like, I think React is very bare metal API. And so we kind of like to be able to go at the low level and so on. But the realization I had is that for people who are newcomer to React and React Native, it's not fun at all, right? So you expect things to work out of the box, like in a very performant way. And yeah, I thought we could talk about it. So what you showed me that we recorded and didn't publish yet was like something pretty crazy, right?
Yeah, like first of all, I want to say, I guess it's kind of fun that if you like track down a real big performance bug, yeah, that is a good feeling. It would be even more fun though if it were just like fast by default.
Yes. The example you showed was, I think, really insane. So you had I mean, it's even hard to explain because it was so magic, kind of.
Yeah, so what I realized, but then like I didn't really like find a conclusion to what was the problem, is that basically we had a rather big SVG in a React Native app, and it wasn't even like drawing something special. It was literally an empty SVG that would not draw anything, and then you would only have to like render 2 or 3 of these, and using the flame graph on the Android phone, you could see that without much going on at all, the performance would drastically become super, super bad. And what then resolved the problem for me a little bit was using React Native screens. So
Because suddenly you would have the problem only for one screen.
yeah, probably, yeah. So it could have something to do with like memory usage, or like having too much drawing work done on the phone, that it yeah, that once you reach a threshold, it seems to bottleneck like crazy. I don't know.
This is cool because I think that this touches on 3 performance topics I actually wanted to discuss. So you use the Android Flame Graph. Did you use Flipper Profiler or the React DevTool Profiler to see the performance?
No, not really. Since what's also interesting is I was not doing any updates to React.
True.
Literally, I was just rendering it and scrolling through a scroll view. So I would say it's not on the JavaScript side
Yeah.
of things. And yeah, like the Flame Graph is a handy built-in tool that you can just enable without having to
Yeah.
enable anything.
One bad performance pattern I've noticed in React Native is that so we want to display vector graphics, and so lots of people use SVG transformer, where you can put any SVG, but then it mounts the whole SVG as a React Native SVG component. So this can have like tremendous. I know it's not the use case you showed me, but it made me think about how to display these graphics, these vectorial graphics on React Native. So I've looked at some apps where they were using this Andy plugin, but then they were mounting to show one icon. They were mounting tons of components, and the rendering time of a single icon would be like quite big. And then you have a list with 10 icons, and things would literally explode. And then I was looking at how do we So for icons, you should use a font, and here the support in React Native is great. But then there are some other vectorial graphics you want to use. If you are using iOS, it works out of the box. So if your SVG file is part of the iOS bundle, and not the JavaScript bundle, you can render it directly, so without mounting any or having any dependencies with React Native SVG, which is cool. For Android, we need the drawable, which is also nice. And then if it's part of the app, you can use it, but it doesn't support the full SVG. So there is a converter, but then there are some things like mask, which are not supported, and which are actually like pretty common in SVG. So it's not a great solution.
Okay, I see. So as is often the case, we hit a wall when it comes to Android support.
Yes. And I'm wondering, we know, I think, that some graphical primitives on Android seems to be somewhat more limited, like the blur stuff. We know that, you were talking about the mask implementation in Android being super slow. And I'm wondering if it's not related, like why Drawable is not supporting the mask. Maybe there's like a technical reason for it. I'm not sure.
Yeah, so what I think is the case is that things like SVG, blur, and masking, they are super well supported in the using low-level iOS APIs, and probably even accelerated using the graphics.
I even heard that they have dedicated chip set for the blur stuff and so on to have it super fast.
That would make a ton of sense. So to bring these blur effects that you have on iOS over to Android might not be the best idea, actually, because in Android, if you want to replicate these blur effects, it's like you're using the CPU to calculate a bitmap of all the pixels, and then you draw it to like an Android canvas. That's just not as efficient as using a graphics accelerated way. So blur view, but without blur view, I think we can live well, but also without mask view and SVG, which seems to also be canvas based, life is hard on Android.
Yeah. I spent a bit of time working on performance. So I've been using the React DevTool profiler, and I think it's really cool. Like the number of insights you get is, I'm getting more and more comfortable using it, and I'm really loving it. And it's just so nice. Like if you make things 3 times faster and 2 times faster, it's just a great feeling. And also everyone is happy, right?
Yeah, for sure. The nice thing is that if you think the performance of my app is not good, that probably you can optimize it a lot.
Yeah.
If you don't make any mistakes, which are actually done really easily,
yes,
then React Native is really fast.
Yes.
But then with one bad line of code, you cripple it really fast. So yeah, I can only recommend everyone to like use these debugging tools to find these lines that, where the culprit of your performance.
Yes, I could not agree more. So React Native performance, first, there is the React performance. So really, and again, because it's so low level, you can shoot yourself in the foot so easily, and especially if you're a newcomer. And I think if you're an experienced React developer, you love it. You love this, that you have only the low-level API to work with, and you have like full control. But I'm sure that for a newcomer, this can be difficult. And I assume, I'm not familiar with Vue.js and so on, but I assume this is where the appeal of Vue, for instance, comes from, is that you get a higher level API, But then for newcomer, it's great because it's like batteries included, right? And you cannot do any wrong, I assume. I have no experience with it. So this is nice. But then, yeah, in terms of React Native itself, so I was always, if people, they were asking me like in Zurich, like startups and so on. So the first pitfall to avoid is always, also because React and React Native is evolving so fast, is that, okay, I'm starting an app. So maybe I want a nice slider for my intro or onboarding. And then what do? You do like for any programming language, you go on npm, you install the package. But so already that's, we don't know how these libraries are implemented. And also because the framework evolves so fast and React evolves so fast, you quickly get such packages to be quite slow in compared to what they could be done. On the other hand, now there is more and more high quality packages for React Native that come in, that are using Reanimated 2, that are using the best practices. If you take React Navigation, it's crazy fast. I mean, the example you showed me, where I think on Fiverr, where I'm not sure if it's even using the native navigator, but it was using V5 with React Native screens. I mean, that was blazing fast and out of the box experience. And there is more and more high quality packages. I guess things are getting a bit more mature. This is nice. But I would say that's the first pitfall where you need to be super careful to not shoot yourself in the foot.
Regarding the thing of React versus Vue, I see the appeal because, maybe React gives you a bit more flexibility. It also gives you more opportunities to really shoot yourself in the foot. And even as, I would say, an experienced React developer, I still code these bottlenecks on a regular basis. So if it's just too hard to do it right, then why bother? Then just use a higher level framework, which which is easier to reason about.
Yeah, I think it's nice because we do our things, we love it, I love it, you love it, but it's sometimes we forget to put ourselves in the shoes of a newcomer. But so I was always super, since the beginning, I was always super, how do you say, not suspicious, but like integrating new packages from the outside. I was always trying very careful. And now, to be fair, the quality, so the number of super high quality packages that are available, like React Navigation, Reanimated 2 bottom sheet, and so on, is getting, there are more and more of these, I guess, which makes sense because things mature. So that's nice. So I was always super careful with these NPM package. Something that came up in the past weeks is that now I'm being super careful with the components which are shipped by React Native itself.
Oh dear.
Yeah, that's the next level.
Which one you are talking about?
Yes.
Is it something with lists?
Yes, but then there is some other, I think you might be surprised. But yeah, indeed, it is flat list. So if you read the React Native documentation for flat list, I was excited because it's well documented. Everything was making sense in terms of the contract they're offering you, in terms of the API. They explain you the trade-offs and so on. And I was like, whoa, this is, virtual lists. I was like, this fits all of my use cases. And I couldn't get it to work as expected. I mean, based on my understanding of the documentation. And then I went on the source code. The source code is, how do you say? I mean, it seems to be a bit not
hard to understand.
Hard to understand, yes. It doesn't seem to be actively maintained anymore. And so at some point, I just couldn't get it to work as I was expecting it. So I decided to implement my own virtualization, kind of. And this was very successful. And I could achieve the result I wanted. But more interestingly, is that for use cases where the flat list was behaving as expected, I actually had even much better performance. So even for the use cases that were working by implementing it myself. So now for me, it's like a component, for instance, which I'm not trusting anymore at all, and I don't think I will ever use it again. And I think this is why, for instance, the effort of doing the lean core of React Native is so great, because you can separate these things, have them maintained separately, and so on.
Yeah, that makes sense. So the flat list implementation, it's pure JavaScript, right?
Yes, pure
it's
JavaScript.
not backed by any, and it doesn't like refer to too many React native internals.
Absolutely, yeah.
So making like your own flat list in like as a user wasn't too hard. So or would you even say that flat list doesn't need to be in the core? It should also be extracted to a third-party package like async storage did, for example?
I think so. I think I'm not sure how it works in terms of ownership, but I mean, right now it seems to be, because I saw a lot of bug issues. I'm not sure what's the state, but so React Native is mainly developed by Facebook, and I think some of the components which are part of the React, and it's like so convenient. You get a scroll view, you get image, you get text, you get view. But some of these components I don't think are actually used by Facebook internally. I'm not sure. But yeah, I mean, it's great that out of the box we have these primitives, but sometimes, we know that image, for instance, also is such a use case. It's so great that out of the box, the image component does so much. It provides such convenience when you get started with React Native development. But then we know that there is many projects which are not using this component to display images, because then the use cases are different, and people want to have more control, right, over, for instance, the image component. So.
Yeah, for sure. So, for example, there's like a fast image component out there, which is kind of suggesting that the default image component that's like a performance problem, I suppose. For image, I would suppose you would have to hook more into the native code and the internals of React Native, but flat list, coming back to this, it seems to be included in React Native, but could well also be a standalone implementation, which makes me think, is there like any library for virtualized lists out there that is a better option than flat list right now?
So I was wondering that, and the only one I find which seemed to be good, but I didn't investigate. So there is one in React Native Web which seems to be super popular, and also based on what I've seen seems to do also the job. And they claim that it runs on React Native as well, but it was not clear to me yet how. So I will need to investigate further. But the closest, but maybe people, they will let us know if we missed a project but the closest I've seen, I think it's there is one super popular project on React Web that we might be able to run on React Native, that we could use for virtualization. So by running more and more profiles, I found, and it's something I know you worked on, I found another component now that I'm kidding. I was about to say I don't trust now in the React Native core, but I'm just joking around. But which you wouldn't think it would be a overhead, and I could increase its performance by 2 times. Can you guess? Because it's something somehow that is related to something you worked on.
Is it maybe scroll view, or is it the text component?
It's a text component.
The text component is slow. Wow. That's the last thing I expected.
So it's not slow, but what happened is, so we use text. So what you do now, because people use solutions, theming solutions like Restyle, for instance. I like Restyle. So you have all your styling done by Restyle, and then at the end you just want to use the native text. So you have a wrapper, right, to the native text, and then also you show icons. And icons, it's just a text component, right? And by profiling the text component and my icons, I was seeing a bunch of tree below these components. I was like, how is that possible? And then by looking at the Text.js implementation, you see that it does a lot of stuff. And mainly, I think it only does one thing. It's pressability, because now text is pressable, right? So the pressability handling and setting up like the handlers, and you have a couple of hooks, and you have some contexts and so on. And by removing it, meaning instead of, because I don't need this stuff, I use Restyle, I use, like for an icon, I just want to show the character. So by using the native text directly, I was able, so the performance was increased by 2 times for one render, and you display text so much in your app that actually I could see also overall performance gain on the app, because there were so many like icons and text displayed. So this one seems to be worth it. A strange one, right?
Yeah, indeed. But you would never expect that like this is literally the most used component in React Native, besides Vue probably. Yes. And because it's so, nobody would even think about looking for performance improvements there.
And I would have never thought about looking into Text.js, and it's really the profiler that showed it to me that something was going on.
Oh wow!
And I was like, how can you have a subtree below text? I didn't get it, which seemed to be slow actually. And I was like, what? So this is where like the profiler is great.
Indeed, I did not take a look at the JavaScript code of text, but so I forked the text component for my animatable text library, and the native codes, like the Objective-C code on iOS, which would power the text component. Let's say it like this: doesn't look like it's so easy for any developer to wrap their head around at what's going on. So there's like so many different styles and text properties, which are like virtualized in a way, in a hopefully efficient way. But I mean, most of the code is from 2016 and still has some to-do comments from 5 years ago in there. So now that you tell me the bad news, I believe you, because I see this. I saw the implementation, and it could be that in this really essential component, we can still get more out of.
Yeah, but at the end we would like a very simple. But I guess now there's so many considerations and use cases. There's no such thing as a very simple text component, but where you give a string, it's an attribute. I mean, essentially that's what you've done with the fork, and it doesn't do anything, right? We give the style. There is no nesting. They just display this text. And I guess it would be nice to have access to such a primitive, because then we can animate it. We can have it run at high performance, but I guess there's probably like some considerations I'm not thinking about.
For sure. And even coming back to the flat list, even if we say that, we cannot trust it, it doesn't seem so performant, it doesn't seem like somebody else has picked it up and made it so much better that it's like obvious and easy to reason about.
Yes,
this is superior to flat list. And this this says a lot about how hard it is to actually work on these things.
Yeah.
Probably Flatlist survived so long because it is so flexible and can be applied to so many use cases. And same goes for text. It supports so many use cases, so many stylings, so many attributes.
Absolutely.
Yes, maybe we can make a more performant virtualization or text easily. That's one thing good, but to be as flexible and cover so many use cases as these components, that's where it gets hard, and that's where you probably also have to introduce more complexity, and this is why we cannot so easily fix these things.